Will study ethers. We already studied definition of ether, classification of ether and nomenclature of ether. Today we will study preparation of ethers and physical properties of ethers. We know that ethers are the organic compounds in which divalent oxygen atom is attached to same alkyl group or two different alkyl group or one aryl and one alkyl group. Example, dimethyl ether, diethyl ether. Preparation of ethers. In preparation of ethers, first method is dehydration of alcohols and second method is Williamson synthesis. Dehydration of alcohols. Alcohols when heated with dehydrating agent like concentrated H2SO4 or H3PO4, it gives either an ether or an alkene depending upon the temperature. For example, dehydration of ethanol by H2SO4 gives ethoxyethane at 413 Kelvin while ethene at 443 Kelvin. Reaction: CH3CH2OH ethanol at temperature 413 Kelvin gives C2H5O C2H5, that is ethoxyethane. Same ethanol at temperature 443 Kelvin gives CH2 double bond CH2, that is ethene. Symmetrical ethers can be obtained from primary alcohols. Secondary and tertiary alcohol gives alkene as the major product at high temperature. Second preparation method, Williamson synthesis. Simple as well as mixed ethers can be prepared in the laboratory by Williamson synthesis. In this method, alkyl halide is treated with sodium alkoxide or sodium phenoxide to give dialkyl ethers or alkyl aryl ether. General reactions: Rx plus NaOR, it gives dialkyl ether. Rx plus sodium phenoxide, it gives alkyl aryl ether. In both the reaction, byproduct is sodium halide. Williamson synthesis. This reaction follows SN2 mechanism. Ether is formed as a result of backside attack by alkoxide or phenoxide ion on alkyl halide. Alkyl halide used must be primary. For example, tertiary butyl methyl ether can be synthesized by the reaction of methyl bromide with sodium tertiary butoxide. Reaction mechanism: tertiary butoxide ion attacks on methyl chloride from backside and removal of chlorine atom takes place in the same step. Hence, this reaction follows SN2 mechanism. And the final product we are getting is tertiary butyl methyl ether with removal of Cl- ion. If secondary or tertiary alkyl halides are used, the reaction leads mainly to alkene formation. This reaction is elimination reaction. Example, tertiary butyl chloride reacts with sodium ethoxide. It gives isobutene as a product. Reaction: tertiary butyl chloride plus sodium ethoxide, it gives isobutene plus ethanol plus NaCl. Students, remember alkyl halides do not give Williamson synthesis. Next point, physical properties of ethers. In physical properties of ethers, we will study state of ethers, physical constants and solubility of ethers. First, physical state and boiling points. Dimethyl ether and ethyl methyl ether are present in the gaseous state. Other ethers are colorless liquids with pleasant odor. Lower ethers are highly volatile and inflammable. Boiling point of ethers increases with increasing molecular mass of the ethers. Example, dimethyl ether having boiling point 248 Kelvin. Diethyl ether having boiling point 308 Kelvin. Hence, boiling point increases with increasing molecular weight of ether. Second point, polarity and solubility. Polarity. As the bond angle in ether is 110 degree, the dipole moment of two CO bond, that is carbon-oxygen bond, do not cancel each other, so it possesses small net dipole moment. Weak polarity in ethers does not affect their boiling point. Here you see in the diagram the bond angle in between oxygen carbon is 110 degree and presence of two lone pairs on oxygen atom. Solubility of ethers. Solubility of ethers in water is similar to that of alcohols. On increasing carbon atom, solubility decreases due to formation of hydrogen bonding with water through ethereal oxygen atom. See in the diagram, there is a formation of hydrogen bond between oxygen atom of ether and hydrogen atom of H2O. Ethers having carbon number 2 to 3 are less soluble in water. Ethers containing carbon number 4 are slightly soluble in water. But the compounds of ether containing 5 or more than 5 carbon atoms are insoluble in water. In this way, today we completed preparation of ethers and physical properties of ethers. Thank you, students.